Hello guys, today we're talking about level order traversal of binary tree. So what is this? This is a way to somehow traverse nodes of the binary tree in this way. You can see this picture and we traverse nodes on horizontal levels, and actually it's some kind of breadth first search. Okay, and we will implement it in Haskell on top of all paths function. In terms of all paths function, which we wrote in some previous video, you can see link at the top. Okay, what we need? Here we can see that we have this polymorphic data type to represent our binary tree. It's polymorphic type of some type A. It's binary tree. It's either the leaf or the node, which contains two branches, which represented as the same as this binary tree type. Okay, recursive definition here. And we have all paths function, which takes on input binary tree of type A, and on output it produces all the paths in this tree. And also I have some example tree here constructed with our node constructors, and some helper function is some safe extraction of the element of the list by its index. So I mean that default Haskell implementation to access the element of the list is failing. It throws the error when the index outbound of the elements of the list, indexes elements of the list. But here our function return maybe value, so when the index is incorrect they receive nothing, and if the index is correct they return the actual element with this number in the list. So let's load our file, load a tree, and run our all paths function. All paths for this tree there, and we can see that our function gives us all paths. And how can we from this information get nodes in the order of levels of the tree? If you look at this, we can see that we can somehow cut these paths by the index. So if I start with 0 index and take every 0 element of this list, I will get the first little cut. If I increase the index by 1, I will get the second level. So the second level is 1, 1, 4 and 4. Of course, where is a duplicates element here, but we can remove the duplicates. And if we do this, we exactly get the level of the tree, and so on. If we take the second index, we start from 0, we get this level 2, 3, 5, 6. Okay, and this is the main idea which I want to implement in this function, in this code. So first of all, we need to write some helper function. I will call it longest. It takes binary tree on the input, and on the output it produces a number which represents the length of the longest path to a leaf. So how can we get it? We have all paths function, and we can apply it to our tree, and we will get all paths. This is a list. So if this is a list, we know that this list is a functor, and we can fmap it with length function. And as a result of this expression, we will get a list of lengths of all paths. And what we need just take maximum of this list. Okay, and I think this should work. Okay, this should work. Let's check this. I will reload the module and call our longest function, and I will get 3. This means that longest path has 3 elements, and we can see here that all the paths have 3 elements, and the longest has also 3 elements. So the next thing, what they need to do, okay, let's take our list index function here, 3 exclamation marks operator. It looks like this. Okay, I will get this 3 exclamation marks and partially apply it to some number, which will be the level of which I want to extract. For example, if I want to extract the first level, it starts from 0 index. Okay, I take this and partially apply it. So, and next thing I want to do is to fmap this over all paths for our tree. Okay, and if I do this, I exactly will get the elements of the first level. Okay, we can see that we have duplicates here, but I can remove this if I will use a set module, and I can remove the duplicates by this function. I just create a simple set from list, and this will remove all duplicates. And actually this thing gives me a first level. If if I change this 0 to 1, I will get the second level, and if I change this to 2, I will get a third level. And I think you catch the idea. We can use this function to get all the layers, and then somehow concat them in one list. Okay. The first thing I need to do next is to build all the functions, partial applied functions of getting the list, the nth list of element. How many levels to cut I have? How can I count this? Okay. You can see that I can create all these, I will call them cutters functions, which cut the certain layer of the level of the tree. Okay, and first of all, I want to create a list of our indexes. Okay, and it starts from 0 and goes to longest path, okay, of our tree, -1. Okay, and each that index I need to for all this index list of indexes, I need to partially apply index function, our save index function, and I will get actually all the functions which I need to apply to every path. So I need to apply this every index function to every path in this list. Okay, and we can do this using the applicative functor. So I will I will copy this code and write it here. Okay, this expression gives me all the functions which I need to apply to our applicative operation to our all paths I need here. And what I will get? Okay, let's somehow give a name to this function. For example, I will call it test function. It will take a tree on input and produce this thing. And let's try to reload our module. And tester. What we can see here. Here they can see what I take exactly all the levels one by one in the list. Okay, and what I need to do next, Next thing I need to do is to group these things into number of into some number of groups, and this number of groups is actually equal to number of our all number of our paths. Okay. So with this mean let's for simplicity I will take this sub-expression and mark it as a function. I will call it cutters. It's take a tree and build all the functions which I need to apply to cut my levels. And okay, and here the next thing we need to group this thing, and for grouping I will use a data.list.split module. It has chunks of function. Okay, now let's look at its type signature. We can see that it takes some number to split this list to groups which has exactly the number of these elements represented by the first argument, int argument. And let's call this thing to group our results. Okay, I need to do chunks here, and the first argument here will be the number of paths. And how can I get the number of paths? Okay, I can get the all paths and pass it to the length function. With the composition I can create a new function on the fly, and I need to apply our tier tree to this, and I think I will get the number of paths here in this expression. And we one step closer to our final solution. Let's reload our module, call our test tier function, and we can see that here I have a groups of levels. One thing I need to do is to reduce our duplicates, and of course I can simply do this with our set functions. I just need to we have a list as a function. We can fmap this and use from list from a set module, and this thing should remove duplicates. Okay, let's check this. Okay, and you can see that here actually I take all the levels, level by level. Okay, and I think this is a level order of the binary tree. Of course, this is not very fast solution, but I think it's very expressive to intuition. So guys, thanks for watching. Push like button, push subscribe button, write comments, and see you later. Bye.